Dear students, welcome back to my YouTube channel MCB ChemTube, and this is an online chemistry tutorial. And to get my previous videos from my personal homepage or from my YouTube channel. And we were discussing about the topic chemistry of functional group second, and today we are going to discuss Benzenediazonium Salt, a functional group, its preparation and synthetic application, and we also discuss preparation method for methyl orange and what are its uses. So as I said, our learning objectives are to understand how can you prepare benzenediazonium salt, a very important intermediate from aniline, and what are the variety of compounds that can be prepared out of benzenediazonium salt, and how the universal indicator methyl orange can be prepared and what are its uses. And coming to benzenediazonium salt, it's a class of organic compound having general formula Rn2 plus X minus. And X minus is an anion, inorganic anion, usually Cl minus or Br minus or I minus or BF4 minus. And presence of N2 group here, you can see this N2 group is giving its name diazonium. And it's a most versatile combination of organic and inorganic component. You can see it here. This part, it is a benzene diazonium salt. It is organic part. This is an inorganic part. And the naming of this salt is done by adding suffix diazonium. You can add suffix diazonium to the parent hydrocarbon. This is parent hydrocarbon from which they are derived, and then it is followed by anion. So in this particular case, parent hydrocarbon benzene and diazonium and anion chloride. Okay, this is the structure of benzene diazonium chloride and how it can be prepared. Usually primary aryl amine, this is primary aryl amine, which react with the nitrous acid to form highly unstable intermediate. This is Arenediazonium salt, this one, and through a process called diazotization, and the nitrous acid is prepared by treating sodium nitrate and HCl. Okay, and this compound Arenediazonium salt is more stable than aliphatic counterpart. That is, if you have an aromatic here, if you have an aliphatic diazonium salt, this is unstable when compared to aromatic one. And aromatic compound, it usually does not decompose when the reaction is kept below 5 degrees Celsius. And normally, aliphatic one decompose. And diazotization reaction of primary aryl amine are of considerable importance because diazonium's group, that is N triple bond N, you have a positive charge here in one nitrogen, can be replaced by variety of other functional group. So N2 can be released and you can substitute with other functional group. And the diazonium groups are replaced by other groups such as Cl or Br or I or cyano or hydroxy or hydrogen, and reagent can be added without isolating intermediate. So you are preparing benzene diazonium salt with amine, aniline with the nitrous acid, you get an intermediate that is called Arenediazonium salt. So without isolating it, you can directly add this reagent and prepare a variety of functional group you can substitute and nitrogen get released, right? And except in the case of fluorine, you have to isolate this diazonium salt and do this reaction. And we will study in detail what are the reactions that can be used. First one, Sandmeyer reaction. In Sandmeyer reaction, you can replace N2 by Cl or both Br or cyano2. And in this reaction, Arenediazonium salt, that is this one, in this you have diazonium salt here on the left side, You can react this diazonium salt with cuprous chloride. You can see here cuprous chloride or cuprous bromide or cuprous cyanide with HCl or HBr or HCl, and you get corresponding derivative. So here in this reaction, diazonium group N2 will be replaced by chlorine in first case, bromine in second case, cyano in third case. And this method is not useful for the preparation of iodo or fluoro. You remember that this method can be used for cuprous iodide, cannot be used here. So how iodo derivative is prepared? You can replace N2 by iodo compound by treating benzenediazonium salt with potassium iodide or sodium iodide and give aryl iodide. This is diazonium salt with the potassium iodide. You get iodobenzene. You can see it here. And you can prepare fluorobenzene by Boltzmann reaction. So what is the reaction? It is a treating aqueous HbF4. It precipitates the diazonium cation into a relatively insoluble diazonium fluoroborate. This is fluoroborate, and it precipitates, and this fluoroborate, which upon heating, you can see it here, heating, it gives corresponding fluorobenzene. So you can prepare fluorobenzene by this method. Next one, you can replace N2 by hydroxyl group. How? By heating benzene diazonium salt with the acid, aqueous acid. This is aqueous acid, H plus and water, and heat it. You get phenol. Okay, so diazonium salt form phenol. And you can replace N2 by hydrogen by treating diazonium salt with the reducing agent hypophosphorus acid H3BO2. So it replaces N2 with the hydrogen. You can see it here. It replaces this part with the hydrogen and it forms benzene. Next one, coupling reaction. Arenediazonium salt are weak electrophile. It can act as a weak electrophile and which can react with a highly reactive aromatic compound such as phenol or tertiary aryl amine. This can act as a nucleophile. So in the case of phenol, you have OH here, it is called phenol. This para position, this one can react with this nitrogen and it form an azo compound. This is called azo compound. And it can react with the aromatic compounds such as phenols, in some cases phenol or tertiary aryl amine. And if you have an NR2 here, so you get corresponding azo compound. This is called azo compound. Okay, right? This coupling reaction. For example, benzene diazonium chloride with phenol, it form an orange solid paraphenyl azophenol, and with benzene diazonium salt with an N-timethyl aniline, it form a yellow solid, that is an N-timethyl paraphenyl azoaniline. This compound. Okay, right. The last one, methyl orange preparation, and this is the structure of methyl orange. You can see it here. And this compound has a very good similarity with our previous example and azo-based compound. Only the difference is you have an SO3H here. Okay. So how this methyl orange can be prepared? Can be prepared from sulfanylic acid. This is sulfanylic acid. And first you can diazotize this one and you can convert into N2X, that is N2Cl minus, by treating diazotization reagent, and you get an Arenediazonium salt, and treating this compound with N-timethyl aniline, right, timethyl aniline, it form methyl orange. This is called methyl. So what is methyl orange? Methyl orange is an acid-base indicator which is widely used in volumetric analysis. It's a pH indicator And this also can be used in textile industry, and they used to dye wool or silk. Okay, in summary, we have learned the preparation of diazonium salt, and this is a preparation of diazonium salt and its synthetic uses are discussed. So this is summarized here. You can make a number of compound out of this intermediate. Okay, that's all. Thank you for watching.